So the 2 is going to be a stretch by a factor of 2. That's going to take our graph and it's going to pull it vertically up. It's not going to change the x values. All it's going to change are the y values. They're going to be pulled upward if it's stretched. What is the -1 going to do to our graph? Right. It's going to move it to the right 1. And what is the -4 going to do to our graph? Down 4. It's going to move it down 4.
That's our asymptote.
That would be our asymptote if we had asymptotes, but in this case, we don't have asymptotes. But what do we have? We have this point right here that goes through the origin, and we're going to call that point our key point. Because when I move this graph left, right, up, down, that point is going to move left, right, up, down. That point is not affected by a stretch, a shrink, or a reflection. And this is a little bit different than logarithms and exponentials because we didn't have a point that went through 0, 0 for logarithms and exponentials. But now that we have that point that goes through 0, 0, this is the point that's going to move left, right, up, down, and it's not going to be affected by the stretch, the shrink, or the reflection. So we can take that point that was at the origin, and we can go right 1 and down 4. This point is going to be on my new graph. Always. It doesn't matter about the stretch, the shrink, or the reflection. That point is 0, 0. However we move it left, right, up, down, that's that point. And we're going to call this the key point, 1, -4. What are we going to use that key point for? The domain, the range, the end behavior. It's going to show up for all of
So
those.
you got that by going right 1 down.
Right 1 down 4 from the origin. That is correct. And we got right 1 down 4 from the equation. All right, cool. Now, I really only need, I know the shape of this graph because we just talked about the shape, right? It looks like take that parabola and like flip it over sideways and chop the bottom half off, right? That's what this graph's going to look like. All I really need is one more point. And we can get that one more point from this 2 right here. So let's go back up and let's look at the original equation that we drew. Okay. What if we were to stretch this original equation? Are the x values, let's say 2 times square root of x, are the x values going to change? No, the x values are not going to change. The x values are not affected. The only thing that's affected are the y values. But this point at 0, 0, how can you make 0 twice as big? You can't. It's still 0. So this point is not affected by the stretch or the shrink. Well, what about this point that was at 1? How do you make it twice as big? What's twice as big as 1?
2.
Just 2. Cool. So the graph's going to look like that if we stretch it by a factor of 2. And now if we move that left, right, up, down, the graph's going to look like that. Move left, right, up, down. What if this, instead of a 2, what if it was maybe a 5? And you don't have to write this down right now. What if it was a 5? This point that was right here, where is it now going to be? It's always going to be that second point that we're going to stretch or shrink. It's going to be 5 above the point where we started. So it's always going to be this 1 over, and we're going to go up 1, 2, 3, 4, 5. So we stretched it. Notice we're taking this graph and we're stretching it vertically. What if it were maybe a negative? What if we were maybe -3 square root of x? It's still being stretched, but it's being reflected. So if we go to that next point, instead of going up 3, we might go down 3. So 1, it's still going to be this very next point is going to be 3 below. That's what that graph is going to look like. Not all of them at one time, obviously. What if we had maybe a shrink? What if we had maybe 1/2 square root of x? Let's do a different color so we can see it. What would that look like? We're still going to go over to that first point, which is at x equals 1, which is 1 to the right of my key point. And instead of going up 1 or up 2, we're not going to go over 1 up 2 or whatever. We're only going to go up a half. And what have we done with that graph? We've taken that graph and we've shrunk it vertically. So that's how we're going to graph these without a table. But if all else fails, guess what you can use to help you graph these? Desmos or a table. A table. So we got 0, 0, 1, 1. It was 4, 2. Technically 9, 3 was the other point. But the 2 points that we want to look at, this is going to be the left or right point. That first point is going to be the left or right up and down point. And the second point is going to be the stretch, shrink, reflection point. Okay? And it's always 1 to the right of our original graph. So, going back to this, we've been stretched by a factor of 2. So this is my original point. It's always gonna be that very next point, which is 1 to the right, and we're just gonna count the number of spaces that that number in front is equal to. And now what's this graph gonna look like? Is it a straight line? No, that's not good. You got the points in the right place, but we know what the shape of the graph looks like. And we know this graph has to be a parabola, kind of turned on its side. And only half of it. We're not looking at the bottom half.
Is that always the case?
Yep, that is always the case. X and Y intercepts we're doing tomorrow algebraically. I know we can look at the graph and say, hey, it's really, really close to 5, but do we know if it's exactly 5? No, so graphically by hand, if we're graphing something by hand, that's probably not the best way to find the X and Y intercepts. Today, we're just gonna talk about the domain, range, and end behavior. The domain, how far left can we go? Just 1 bracket, because we can actually go all the way to 1. We can't just get close to it, we can actually go all the way to it. And what about the range in this case? -4 is that bottom Y value, and we can go up as long as we want. When we do the end behavior, guess what we're gonna use for the X value? We're gonna use those numbers that we just wrote for the domain. And what numbers are we gonna use for the Y values for the end behavior? The numbers that we wrote for the range. So as I get closer and closer to X equals 1, I get closer and closer to that key point. What are the Y values going to end up equaling? -4. And as we go further and further to the right, what are the Y values gonna end up equaling? Infinity. All right, cool. All right, last one, just very quickly. We have a reflection. The negative is a reflection. So this graph is going to go down to the right instead of up. The negative tells me this is a reflection. It is a reflection over the x-axis. Technically, there are reflections over the y-axis, which we typically don't do in Algebra 2, but that would make my graph point to the left instead of to the right. But we're probably not going to do those in this class. What's the +2 going to do to our graph? It's going to move it left 2. And what is the +1 going to do to our graph? Up 1. So I'm going to start at the origin. I'm going to go left 2 and up 1. That point is on our graph, and we're going to call that our key point. Now, very easily, we can put that next point on there. We're going to use this idea of the stretch, the shrink, or the deflection. There was no stretch, there was no shrink this time, because that's a -1 in front of the graph. So what's going to happen? It's just going to be this very next point. Always 1 point to the right, because that's that second point from that original graph that we did. And it's going to be 1 below that. So the graph's going to look like that. What if it were? It's not. But what if it were like, say, -1/3 times the square root? What would that look like? Just to talk about it for a second. We would go down like 1/3 of a space. It would look something like that. If it was -1/3. Was that? Yeah, just eyeball it. There's no way we can do that accurately. No way we can do those accurately. Domain, range, and behavior. We're done with our notes for today. How far left does this graph go? -2. How far right does it go? Infinity. This graph has been reflected, so the range is going to be a little bit different than the first two we did, because my graph is now going down instead of up. So how far down will our graph go? It'll go down to -infinity, and it'll go up to the y value of the key point, which is 1. I didn't know what other better word to use other than key point. Technically, vertex would be a good word, but it's technically not the vertex because it's not a parabola, and only parabolas have a vertex. So I didn't really know what word to use. So I used the word key point. All right, as x goes to -2, y goes somewhere. And as x goes to infinity, y goes somewhere. So as we get closer to -2, what is this y value getting closer to? +1. And as we get closer to the right, as we go further and further and further and further to the right, our graph is getting closer and closer to